Welcome to today's tutorial. We're diving deep into a captivating topic that is set to revolutionize the healthcare industry, implementing a blockchain-based healthcare system. In this video, you will learn how to design and implement a secure, tamper-proof record-keeping system for patient data using Java and blockchain technology. Before we get started, let's take a moment to understand what blockchain is and how it applies to healthcare. Blockchain is a distributed database that ensures secure, transparent transactions among multiple parties. In healthcare, it allows for the secure sharing of patient data across medical providers, leading to improved patient care. Now, let's outline what we're going to build in this tutorial. We will create a simple blockchain system that allows healthcare providers to store and retrieve patient records. We will cover four main components: blockchain structure, transaction structure, a simple smart contract, and client interaction through a Java application. We'll start with our blockchain structure. Let's create a class named blockchain that will manage our chain of blocks. Each block will contain a list of transactions, a timestamp, and a reference to the previous block's hash. This blockchain class starts with an empty chain and immediately adds a genesis block to start our blockchain. The genesis block is the first block in the chain, and it doesn't reference any previous block. Note that we're using an array list to store our blocks. Next, let's create our block class. Each block will have an index, a list of transactions, a timestamp, a hash of the previous block's hash, and its own hash. Within our block class, we store the crucial data elements mentioned. The calculate hash method will later contain logic to produce a unique hash for each block based on its contents. Now, let's create the transaction class. This class will represent a transaction involving a patient's healthcare data. This transaction class holds data such as the patient's ID, the doctor's ID, the health information, and a timestamp that records when the transaction occurred. This is crucial for tracking when patient data was modified or accessed. With our data structure set in place, let's implement the functionality to add a transaction to the blockchain. We'll need to add a method in our blockchain class to create and link new blocks. In this method, we retrieve the last block, create a new transaction list, add the new transaction, and then generate a new block which we append to our chain. This encapsulates the core of our blockchain. Now, it's time to create a simple smart contract. Smart contracts are self-executing contracts with terms directly written into code. In our healthcare application, we might want to ensure that only authorized healthcare providers can access certain patient data. The smart contract class manages a set of authorized doctors. It has methods to authorize doctors and to check their authorization status. This will help keep patient data secure, allowing only verified individuals to access it. Next, let's build out the user interface of our Java application to interact with our blockchain. We will keep this simple with a console-based interface using a scanner to read user inputs. The main class will set the stage for the user interface. Initialized at the start of our program, it contains instances of both our blockchain and smart contract. We import the scanner to get user input for transactions. We will set up a simple loop that takes user input. Users can add transactions and check authorized doctors. First, let's prompt users to add a transaction. In this block of code, we first ask the user for the necessary details for the transaction. If the doctor is authorized, we create a new transaction, add it to the blockchain, and confirm success. If they aren't authorized, we inform the user. We also need a method for doctor authorization. Let's integrate that into our user interface, allowing administration to add authorized doctors through the interface. Now, our main loop needs to continuously ask users what action they wish to perform. Let's wrap this input logic into a loop for user convenience. Here, we're presenting a simple menu-driven approach. The user can choose to add a transaction, authorize a doctor, or exit the application. Depending on their choice, the relevant logic will execute. To finish off, let's ensure we can view the blockchain and the transactions added. This will enhance our application, providing visibility into the stored data. With this code, we're iterating through the blocks in our blockchain and printing them out. This helps users verify the transactions that are stored securely. Now that we've covered everything, let's summarize what we have built. We created a basic blockchain structure, defined transactions for healthcare data, implemented authorization through smart contracts, and built a user interface for interactions. This gives healthcare providers a solid foundation for securely handling patient data. In a real-world application, you'd want to ensure that your blockchain implementation is secure and robust, considering privacy techniques such as encryption and possibly integrating with existing health databases. You might also consider GUI interfaces or mobile applications for more user-friendly access. Thank you for joining me in this interactive exploration of implementing a blockchain-based healthcare system. Don't forget to like this video, subscribe for more content, and let me know in the comments if you have any questions or topics you'd like to see covered in the future.